to email or anything, so you just wait for 20 seconds. Just got notification. All right, so on Friday, these are the values we calculated. A 30-degree angle is attached to a point on the edge of the circle, and that point to get to the edge of the circle would be going over the square root of 3 over 2 and up to 1/2. So because the opposite side of your triangle is the y distance that it takes to get up to that point, and the adjacent side of your triangle is the x distance that it takes to get up to that point, it then kind of corresponds that your sine is opposite or y. The cosine is adjacent or x. Since the hypotenuse is 1, you're dividing those by 1, and that's why it's just the y and the x. So then, if you know a 30-degree angle are all of these values, and that 30-degree angle is pi over 6, you can then take those values and kind of translate them into the next quadrant. Any pi over 6 angle, as you go down your chart, should have the exact same values, except if it's in a different quadrant, you have to take into account that the second quadrant has different plus and minus values assigned to the x and the y. So Chelsea, if we're in the second quadrant, any point in the second quadrant has what happening with x? It's negative, and y is positive. So because you're in the second quadrant, all x values are negative because you have to move left to get to the second quadrant. And when you move back left, x is negative. So when you look at the top, anything that contains an x, which would be the cosine, the tangent, the cotangent, and the secant, all of those answers should be negative. So using the pi over 6 values, translating them down to 5 pi over 6, because it's now a family of angles, any pi over 6 angle will have the same values. So you can literally not calculate. Once you've done the calculations, we're just translating them down. So I'm rewriting the values that I have above for pi over 6. And then based off of what Chelsea told me, any value for x in this list now needs to be negative, because anything contained with x is in the second quadrant. So x in the second quadrant has to be negative. So those functions that contain x are also negative. So in the second quadrant, when you look at your group of angles, 1, 2, 3, 4, the 4 angles there, your first column for sine and the last column for cosecant should be positive. But those 4 in the middle should all be negative. So just kind of look and make sure you have all 4 of those being negative because they contain an x, and x is negative here in the second quadrant. So when you move into the third quadrant, which takes us down to 270, Eris, what's going on with the x and the y values in the third quadrant? They're both negative. Yeah, we have a negative x and a negative y. So the way that I would get my angles then is I would use just the same values as pi over 6, but come down to 7 pi over 6 since it has a 6 in the denominator, translate the values again. But she said that both x and y are negative. So sine is y, cosine is x, they're both negative. The secant is 1 over x, and the cosecant is 1 over y, so they're both negative. But Eris, what happens with the tangent and the cotangent? Because it's y over x or x over y. Are they going to be positive or negative? Why? Yeah, the negatives cancel because you have a negative y divided by a negative x, and they cancel. So the tangent for this third quadrant should be positive because you're taking a negative y and a negative x, and both negatives mean that they become a positive value. So whatever you have for 5 pi over 4, 4 pi over 3, these all should be positive for the tangent and the cotangent because it's y and x. And then in the last quadrant, Libby, which one of those values are negative in the fourth quadrant, x or y? the y, because we're down here. So you can move right for x, but the fourth quadrant means we have to go down for y. So positive x, negative y. So again, looking at my angle, we're dealing with pi over 6. So a pi over 6 angle in the fourth quadrant is 11 pi over 6. So again, we've got the same values, writing them now for the last time. And now all the y's have to have a negative. So sine is y, cosecant is 1 over y. Tangent is y over x, so negative y divided by positive x means it has to be negative. Cotangent is x over negative y, so that has to be negative. So that means the sine and the secant functions are the ones that are positive because they're the ones that only contain x. So it's really focusing on the value from the first quadrant and then using that value from the first quadrant and thinking, where is the angle located? Does that mean the angle has a positive x or a negative x, a positive y or a negative y? I'm going to send the solutions through Remind to all of this so that you can check your work to make sure that you have them correct. And this chart is a great chart to use to check your work. I don't want you to rely on it and by like simply looking at the chart and just copying down all the answers because then you will not really learn it. You're just copying stuff that you've already done. But if you use it to check your work as a reference, then it really is a good resource to have. So I'll make sure to send them through Remind so you do have the correct solutions. So I'm going to ask you to kind of go backwards in the packet to 2H. And we're going to see if we can try and like take this and apply this information and see how we can use it to find some values. But I also want to show you that this truly doesn't have to be memorized. So how can we take a piece of this and try and work through some problems without actually memorizing all of it? Somewhere. Here we go. So on Friday, we talked about the 6 trig functions for any angle and the relationship of those 6 trig functions, which is what we've used to try and help us find all of the values in the chart. So the problems underneath here, one is to evaluate the trig functions at, it says the real number. The real number would just be the angle that they give you. So an angle is considered a real number. So it isn't a radian value, it isn't a degree value, it just isn't, it's an angle, it's a location on the unit circle. And I'd like you to travel down to D. I thought we'd do the last 2 problems as examples. I like those angles. So for your D, you have 3 pi over 4. And then, nope, I'm not at D. There we go. So for D, we have 3 pi over 4. So some of your homework tonight will give you a location of an angle, and you have to think about that angle and where it is on the unit circle. And if you're not sure where 3 pi over 4 is, the easiest thing to do is to make a picture. So spatially, if you can't kind of look in your mind and think 3 pi over 4, right, that's located in this quadrant, then I'd say make yourself a little sketch. And I think that's the easiest thing to do to try and approach any of these problems is to find the location of the angle by just drawing a little diagram. So if the denominator is 4, that means my top half has 4 pieces, the bottom half also has 4 pieces. So really we have 8 pieces of the pie, 4 on the top, 4 on the bottom. And we're going to have 3 pieces of pie because it's 3 pi over 4. So every angle that we will draw will be in standard position. It always starts on the positive x-axis and it moves counterclockwise if it's positive. So counting 1, 2, 3 takes us to this location here in the second quadrant. So there are 2 things that will be important when you're trying to get a value or a point on the circle. The one thing would be the denominator of the angle you're working with. It's a 4. So every pi over 4 angle has the same ordered pair. Does anybody know what the ordered pair is for a pi over 4 angle? Virginia. So square root of 2 over 2, square root of 2 over 2. Because this angle is in the second quadrant, after you have this value, and this works for any pi over 4 angle, then look at the location of your angle and decide which should be positive, which should be negative. So this goes for any pi over 4 angle, but because pi over 4 is 3 pi over 4 and it's in the second quadrant, the x value has to be negative, the y is positive. So you're going to think about the denominator, because that denominator has a special ordered pair associated with it, and then the location of your angle will tell you what that ordered pair should be, positive versus negative. From this ordered pair, that's the part that you have to memorize, the ordered pair part, we can then find the sine and the cosecant, and I'm going to kind of stack the buddy functions vertically. The cosine and the cosecant, nope, the secant, and then the tangent and the cotangent. And I'm using the value t for the angle just because that's what they give us. But anytime you write a function, you need something sitting next to it. So the sine is the function, the t is the variable part. So when we were doing natural log, you never just wrote ln, you had lnx, ln2. But it never sat by itself because you have to take the natural log of a value, you have to take the sine of a value. So Michael, by using the information that we know about triangles and ordered pairs, the sine would be which value of the ordered pair?
Either the opposite or the hypotenuse.
The opposite over the hypotenuse, and because our opposite is y, the sine is the y of the ordered pair, and in this case it is
The y value?
Yep.
So I just square root of 2 over 2.
just square root of 2 over 2. And again, that is because in a triangle, to get to a point at the top, you're moving up a distance of y over a distance of x. So the opposite over hypotenuse, the opposite is the y. Hypotenuse is always 1. So looking again next to it, the cosine would be the x because it's adjacent. The adjacent is the x value. And in this case, the x is negative square root of 2 over 2. Separate them there. And then, how do you find the tangent using a triangle? What two sides of the triangle are the tangent? Y divided by x, because it's opposite divided by adjacent. So in this case, we take the square root of 2 over 2 divided by negative square root of 2 over 2. What's that make, Cup? Negative 1. So the tangent's negative 1. So we can find all of that information just by knowing an ordered pair. And the fact that the ordered pair has a cosine value of x and a sine value of y. So then the ones underneath, they're called reciprocal functions. Chelsea, what does it mean if it's a reciprocal function?
There's 1 over it.
Yeah, there's 1 over it. So what would you do with the square root of 2 over 2?
You make it 2 over square root of 2, which you have to simplify.
So,
2 times, or actually just square root of 2.
yeah. So it's 2 over the square root of 2. So you're taking the reciprocal of the square root of 2 over 2. You're flipping it. And then she said multiplying it by the square root of 2 over 2 just becomes the square root of 2. Because this would be 2 square roots of 2 over 2, and those 2's cancel. So it's just the square root of 2. So doing the same thing for the cosine, we know it's x, the cosecant, or I'm sorry, the secant is 1 over that value. So take your cosine value, flip it, so 2 over negative square root of 2. And it's going to be negative square root of 2. Because the sine was positive, the cosine is negative, they have the same value because it's a 45, 45, 90 triangle. And then the cotangent would be the reciprocal of the tangent. So whatever you have for tangent, you're taking 1 over that value. Libby, what's 1 over negative 1?
It would be negative.
Yeah, it's going to be negative 1. So you're taking 1 over negative 1. You take 1 over, you already found the tangent, so take 1 over it, flip it around, and you get negative 1. Questions? So if you look at letter E is the same thing, just gives you a different angle. So you have a negative pi over 3 angle. Ooh, that circle's rough looking. Try again. A little better. So because it's pi over 3, that means you have 3 pieces on the top and 3 pieces on the bottom. So when it is negative, how does that change the location of your angle? Chelsea? You go clockwise, yeah, we go underneath. So the angle starts at the same place, but now you're moving under the angle in the clockwise direction. So we're currently at like 3 o'clock, we're gonna move to like in between 4 and 5 o'clock. So here would be the angle that we're looking at. So we have the location, the denominator is a 3. So we need to think about the point on the circle when the denominator is a 3. Grace, do you know what the point on the circle is when you have a pi over 3 angle? Perfect, 1/2 square root of 3 over 2. And because it's in the 4th quadrant, that means it's negative square root of 3 over 2, because the y is negative. So we're getting the point, the ordered pair, then we're assigning a positive and a negative value to x and y based off of the location. After you have that, we can then find, just like we did above, the sine and the cosecant, the cosine and the secant, and then the tangent and the cotangent. So see if you can calculate those just by using the order. So even drawing a triangle and labeling your vertical side x, your adjacent side y, so that you have something to look at. If you're not sure is sine x or is sine y, then you know that you've got like the opposite side. You have the triangle drawn, opposite is y. So any picture that you can make yourself will make it easier to kind of think about where things are located, which is assigned to each function. So Virginia, if we have 2 over negative square root of 3 for the cosecant, what does that reduce to then?
It would be -2 square root of 3 over 3.
Perfect, negative 2 square root of 3 over 3. The cosine is 1/2, so Virginia, the secant would be 2. And notice both of them are positive because they have a positive x. The 4th quadrant has a positive x. And then, Jenna, how about the tangent? What do you have for that one?
-square root of 3.
So we're taking negative square root of 3 over 2. You're dividing that by 1/2, which really means you're multiplying by 2 over 1. And then, Jenna, the cotangent is?
-square root of 3 over 3.
Nice job. So 1 over the tangent. So use the answer that you have. Take 1 over it. 1 over negative square root of 3 is negative square root of 3 over 3. Questions? So before we flip to the next page, just to kind of give you an idea of the easiest way to think about this. There we go. I would say what a lot of students will do on a test or a quiz is to make a little sketch of the first quadrant. So this is my 0 degree angle or 0 radians. This is pi over 2. And then they would just quickly draw in 3 other angles. Pi over 2, pi over 3, pi over 4, pi over 6. Doesn't have to be nice and neat. They would label the ordered pairs with each of these points. So this is 1, 0, up at the top is 0, 1. And then they list the 3 other angles, and it's like the corresponding ordered pairs. So a half, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2. And then this one here is the square root of 3 over 2 and 1/2. Me talking and working through that took probably less than a minute. But then they have a picture, a visual aid to work on then, so that you've got something to go on, because everything is just based off of those 5 values. So 5 ordered pairs, not a whole bunch of ordered pairs, but 5 ordered pairs. If you can memorize those 5, you should be able to answer any question that we talk about when we pertain to angles, as long as you know where the location is. So if you can draw the angle, you can have the angle values, its family of values. So take the angle location, the family of values, and then that'll give you that positive or negative part. Which one's positive, which one's negative. I'd say like 75% of like people, students that I've had in the past, any quiz, they quick just draw this sketch. And then they kind of use that sketch to create the rest of the values or to answer questions pertaining to the angles of the unit circle. Questions? So we're going to do a little bit of summary at the top. Like the next page is kind of just a summary page. So if you want to flip it over, just to summarize all of this information. So at the top of your page, we have angle theta is in standard position. We're creating an angle where the terminal side creates a point. That just means the end side creates a point. So draw yourself an angle where the end of that makes a point on the edge of the circle. And that point is just xy. It could be anything. To get to that location, we really could make a triangle, because I could move over the distance for x, up the distance for y. And now we have a triangle created so that we can kind of associate any angle with SOHCAHTOA. So based off of SOHCAHTOA, we should be able to calculate any angle based off the opposite, the adjacent, the hypotenuse values. So see if you can fill in the 6 trig functions down below. Again, if you don't have them memorized, you now have a diagram. So here's the angle. Sine is opposite and hypotenuse. Well, hypotenuse is 1. It's a unit circle. So opposite over hypotenuse means sine is y. Cosecant is its reciprocal. So if I know the sine, we can find the cosecant. The cosine is adjacent over hypotenuse. Well, the adjacent is x, hypotenuse is 1, so that means it's just x. The secant would be 1 over it. And then the tangent is opposite over adjacent, or y over x. And the cotangent would be the opposite, the reciprocal x over y. So I think there are 4 remaining questions, and those 4 kind of just get you to think about domain and range again. Every function, if it's a function, has a domain and a range. Actually, any graph has a domain and range. It doesn't even have to be a function. We can create a domain and range for every graph. But the domain and the range of sine and cosine are a little weird because, I mean, we're talking about x and y, but that's relating to the ordered pair on the circle. When we actually talk about the domain of sine and cosine, the domain would be the values of the angle. So when you're finding the domain, you're really thinking about the values of the angle, because that's your input. We're thinking about an x value, which is really the angle. The output is the answer. So when you think about an angle, can an angle be positive? Can an angle be negative? Is there a lowest value an angle could be? Is there a highest value an angle can be? Or can it be anything? be anything. So the domain of the sine and cosine function is negative infinity to positive infinity. Because angles are allowed to be extremely large. I just spin around the circle a whole bunch of times. And they can be extremely small. They're allowed to be negative. So your domain can be anything. You can plug any angle into it. It doesn't have a restriction. However, the range would be your answer. That's your output. After you have the sine of pi over 3, the answer is the square root of 3 over 2. So the range would be your answer. When you did that trig chart, does anybody know what the lowest value you had in the trig chart and the highest value you had in the trig chart was? Virginia? Say it again. 0 and 1. Well, I agree with the 1. So for y, my point up here was the point 0, 1. And down here, the point is 0, negative 1. So the sign will go from negative 1 to positive 1. All the values are only in between it. Because like you have a 1/2, you have a square root of 2 over 2, you have a square root of 3 over 2. They're all less than 1. For the cosine, it's the same exact thing. Because my first point for cosine is 1, 0. My second point for cosine is negative 1, 0. So when you're thinking about range, it's the answer. After you plug in the angle, what is the answer? That's the range of the function. So your homework tonight, 9 through 12, 23 to 37, odd. It'll work with the unit circle, or it'll just get you trying to think about x and y. If this is your point, your x value is the cosine, the y value is the sine. Can you calculate all of the 6 trig functions? And then as I said, tomorrow we're just going to kind of wrap it up. There's a couple of other notes that we'll look at tomorrow. Not a lot. Little quiz at the beginning of class again tomorrow.